Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Muhammad Fareez Razali. My number matrix is 231091145. And in this video, I will be presenting and demo my power wall simulation for our PSE OEL Lab 3 about distribution system using a shunt capacitor. Okay, so for in this lab, for this OEL, the main objective of this work is to analyze the system performance before and after we installing the shunt capacitor on the diagram lah. Okay, so let's see. Okay, in this diagram we can see that we present a simple power distribution system which is consisting of first slack bus. This one we call a slack bus. So you can see that generator we have a label slack in there. Okay, a slack bus is acting as the main power source. So you can see here. Okay, and then we can take a look from the transmission line. So transmission line is connecting several buses, which in this case is connecting from bus 2 to bus 4, bus 2 to bus 5, and bus 4 and to bus 5. Okay, so load that consume both active power and reactive power, which is a megawatt and megavolt ampere reactive, or we can also call it MVAR, and a generator at the receiving end, this one, and also measurement indicator showing current loading in percentage, as you can see here, and also voltage PU and power flow. So most of the loads in this system are inductive, which cause high reactive power demands. So let's get started. For first one, we start with a case one system before is there a shunt capacitor. Okay, so as you can see, let me run it first. Okay, here we go. So this is without shunt capacitor. I already turned it off. Okay, so what we can observe from here, the system draw a large amount of reactive power. So, okay, first we can take a look from the slack bus. So you can see that slack bus supplies around 191 MVAR. And then there's a several transmission lines show the high current loading. For example, we can take from the one branch, this one. So this one you can see that it reach 59% in here. And then there's another branch that goes up to 79%, which is nearly to reach 80%, which is nearly high lah. Okay, so bus voltage are relatively low with one bus dropping to, you can see example like this one, bus number 5, 0.94 pu. You can see here, very relatively low lah, which one bus dropping to 0.94 pu. So the overall power factor is very poor, if you can see from here. So inductive due to the high, how we call it, high inductive reactive current. So the problem that we can identify from here is high reactive current, increased line current, and some of them is also increased current caused by the higher I2R losses. And then the voltage drop occur along the transmission line and the system operate less efficiently. So that's what I can conclude from this situation lah. Okay, but wait lah. So before that, before we go to the next tool, I'm gonna show the table. So here is the value. So it's so more easier. So this is a nominal kV for each bus. You can see here. We can see the table, the value for nominal kV, pu volt, volt kV, angle, generator megawatt, generator megavolt ampere reactive, or we can call it MVARs, load megawatts, and so on lah. So this one, the value of it. Okay, now that's all for the part for no capacitor. So let's go to the next second case, which is the half a capacitor. So this one I'm gonna pause. So I'm gonna start from 0 again. Okay, so this is with capacitor. This one already on. If this is the color right on your capacitor, that means it's on. Okay, so let's run it. Let's check it if it works. Bismillah. Okay, here we go. So this is when we adding the shunt capacitor. This is case 2. Okay, so let's we observe the system. Okay, so what we can see from here, the reactive power supplied by the slab bus reduced significantly from 191 MVAR, but now it's about become a negative 29 MVARs in here. You can see that the difference before, the one with no capacitor. But now you can see the line current loading is clearly reduced. For example, from here just now is a 59%, right? From the no capacitor, but now with the capacitor is reduced. It's decreased from 59% to 49% right now. And another branch that which one? This one, another branch is reduced from 38 to 35% just now, if I recall that. Oh yeah, this one. So this one from bus 4 and bus 5 to bus 5 is 38%. But now, if you can check, it's reduced, decreased. Okay, and then we can also see the bus voltage also improve. So voltage increase from just now from here, the one with no capacitor, it just as 0.94 pu, right? But now you can see that now voltage increase from 0.94 pu to around 1 for each, or maybe around 1 to 1.02 pu lah. The generator now supply and then the generator now supplies less reactive power, indicating the improved system balance. So okay, so what we can see from here, the reason why capacitor installed, why shunt capacitor is used is because the shunt capacitor installed to supply reactive power to be locally, and then it also helps to reduce the reactive power demand from the source, and also improve power factor, and reduce line current and losses. It also improve the voltage stability lah. So instead of reactive power traveling through the long transmission line, it is supply near the load lah. So okay, so let's check the table for every values. Okay, this one. So here's its nominal kV, PU volt kV, angle, generator megawatt, generator MVARs, load MVARs, and also switch shunt MVAR. This one because we add capacitor on the bus 2. So here's the value. Just now, no capacitor, we don't have this one because we don't put no capacitor lah. So that's all. This is the value. So you can see it's very stable. So okay, let me pause first. Okay, so performance comparison, we can see that how to say that we can see that shunt capacitor effectively compensate the reactive power, and then line loading is also reduced, which is able to improve the system security lah. And then voltage level are maintained within acceptable limits, and overall system is efficiently improved. So in my conclusion lah, from this lab 3 OEL, we can say that reactive power compensation is very essential in the modern power system. Inductive can be caused poor power factor and voltage drop. And then other than that, what is it? So we also learned something new about installing a shunt capacitor is simple and effective solution in this case. This machine clearly shows the improved voltage, reduce current, and better system performance lah. So this is demonstration why shunt capacitor are very widely used in industrial and transmission networks. So I guess that's all for my demonstration. Thank you for your attention.